time is it? Hi, graphing a quadratic given the equation. So we have a lot of different equations of quadratics that we know of. Right? And the first one is the standard that we've known and that we've used a lot. So where we have ax squared plus bx plus c. This is a vertex form where h and k is the actual vertex. We're going to use something called the modified vertex form. And we are going to just really call that the vertex form. Okay, so we're not going to use this a lot, but maybe you might see it someplace else. All right, you also know that if a is greater than 0, this is your a. If you remember this from geometry, it opens up, makes a smiley face, it's happy. And if it's negative, it opens down. All of them have a vertex. So remember, if I draw a parabola here, the vertex is the point right there that the axis of symmetry goes through, and every point on either side has a mirror. So if I have a point here, it will have a mirror on the other side of the axis of symmetry. The only one that doesn't is the vertex, because it's right on it. What you may not have known is that a parabola can be formed with a focus and a directrix. So a focus, the focus of a parabola is inside the parabola, the directrix is outside, and the distance, and this is where a parabola comes from, the distance between the focus and the parabola and the directrix is exactly the same. And that's how it was formed. Any point here has a point the same exact distance down to the directrix. And that's how we created this fantastic figure that we have here. Okay? Now we have a special distance here. This special distance between the focus and the vertex, okay, this one is the one that comes in our formula. So our formula is x minus h squared equals 4p y minus k. So that distance is this p right here. Okay, that distance is exactly the same as the distance as we just spoke of, because it's always the same. Between the focus and a point on the parabola is the same distance as from the vertex to a point on the line. So that P is an important point. Also, we see that H and K are our vertex. Just like in a circle, you change the sign. If this is negative H, this is positive H, negative K, positive K. So it changes the sign when you plug it in or when you take it out. Okay, so what we're going to be doing today is this. If you are given an equation, can you identify and graph a parabola? Okay, so we're going to do that. So given an equation that looks like this with the pieces plugged in, can we write an equation? And tomorrow we're just going to go the opposite way. Given the directrix, vertex, whatever, can you write the equation? You might notice a few things. As P changes, it widens or narrows. The parabola gets wider or skinnier. The focus is always on the inside. Remember, innie. Is that a word? I don't even know. The directrix is always outie, out of the parabola. And the directrix is higher than the... Okay, and then you can read that stuff. So here are a few examples. We're given an equation here, and we want to identify the vertex, the focus, and the directrix, and then do a little sketch. Okay, so the vertex should be the easiest one. I'm just going to call it V. Okay, I'm going to call this F, and I'm going to call this directrix D. Okay, the vertex should be pretty easy. We just change the signs here and here. So x goes with x, so x minus 2, so positive 2 is the x coordinate, and 3 is the y coordinate. There is our vertex. Magic. Okay, so 2, 3, right there. The next thing we need is our P. So that's the next thing we look for. The P comes from whatever's next to the non-squared unit. So in this case, it's the y, and it will always be for us. So P is 12. So to find P, we just take it and divide it by 4. Because remember, the equation is 4P y minus k. And then we have this part there. So this is 4P. So whatever this number is, we divide it by 4, and that gives us that distance between the vertex and the focus. And it's positive. Since it's positive, it will be opening up, so the focus is going to be up here. And then down 3 is our directrix. So we just have to identify those points. So it's saying identify, let's do that. So what is this point? Well, all I did was add 3 to the y-coordinate. So you can either just add 3 to the y-coordinate, or you could just move it up and plot that point. So the focus is 2, 6. And the directrix, this is a horizontal line, so that's y equals 0. All right, now to graph this guy, it will be easier if we have 2 extra points. And the easiest way to get 2 extra points is figure out this distance right here. This distance is 6. So from the focus to the directrix is 6. So if I just take 6 and I count out 1, 2, this way, I'll count more obviously. 1, 2, 3, 4, 5, 6. That's a point right there on the parabola. And 6 the other way too. 1, 2, 3, 4, 5, 6. This way. And there's 2 points there because the distance from the focus, the focus to the directrix is 6, and focus, this will be the parabola, has to be 6. So that's the easiest way to figure out 2 more points, and it just makes it a more accurate graph there. Okay, so let's try these 2. Alrighty, so first, find the vertex. It's going to be the easiest thing to do. So x, there's nothing next to the x, so it's just 0. And then y is 2. That is our directrix. Whatever. It's our vertex. P is whatever this number is, divided by 4. So that is negative 1/2. First thing you should notice, it's negative. So this parabola is going to go down. And second, it's a fraction. You may want to get your calculators out. All right? So 0, 2, right here, is our vertex. Our focus, now this is opening down, so our focus is going to go down 1/2. Now I made these this graph have a half, so that makes it a little easier to do. And up 1/2 for the directrix. The 2 extra points that you have, remember this distance here is where I'm going to get those 2 extra points. This distance from the directrix to the focus is 1 whole. So from the focus to the parabola is also going to be 1. So I'm just going to 1 this way, and now I have 2 points. This is a sketch. It's not beautiful, but there it is. So our equations, we can write all of our equations out now. So let's do focus first, the point. Look here, this is our focus. So it's at, it is at, the x-coordinate is 0. Okay, the x always matches the vertex. I don't know why I'm not drawing here. There we go. X always matches the vertex here. And then the y is this point right here. So it's 1.5, or as I like to put, 3/2. The directrix is always a y equals, and it's y equals 2.5, or 5/2. Good. Next. And final. Oh, goody. Okay, so this guy, vertex, is the easiest thing to start with. Just be careful, it's in a different order. That's the x, and the y is over here. The p is 1/2, it's this number, divided by 4. So if you remember doing math in long ago, whenever you're dividing fractions, you keep this the same, change this to multiplication, and flip. So it's a keep, change, flip situation. So you get 1/8, or break out that calculator and do it that way. So it's negative 3, 1 is our vertex. I have to go up an eighth. It's positive, so the focus is going to be up, and the below is going to be down. Is going to be the directrix. 2 points, so 1 point is going to be here, the other point just to create a somewhat accurate picture of the parabola. It ain't beautiful, but whatever. It's a sketch. So remember, the focus always matches the x value. It's the y. You take 1/8. To figure out what this value is here, you simply do 1/8 plus whatever y was to start with. Yes, because we're going up, we're adding the 1/8. I'll say 1/8, but that would be 9/8. Okay, or some alternative way. So, and then down for the directrix, to figure out what the directrix is, it's, again, you start at that 1 up here, and you subtract an eighth. So that would be 7/8. So it would be y equals 7/8. Done.